The element assigned to me was promethium. The general information about promethium is that the atomic number is 61, the symbol is PM, and the atomic mass is 145. It's in the F block, period 6, and the lanthanide group. The top image shows the pure metal, which has a silvery appearance, and the bottom image shows the salts of promethium, which has a glowy appearance, and it tends to either be pale blue or green, and this is because of radioactive decay. Radioactive decay is the process by which an unstable atomic nucleus loses energy by emitting radiation. It was predicted to exist in 1902 by Bohuslav Bronner. It could not be confirmed because of the difficulty to separate it from other elements. It was confirmed to exist in 1914 by Henry Moseley. We all may know Henry Moseley as the father of the modern periodic table. He is the one who arranged the elements by their number of protons. It is between neodymium and samarium. It was first produced in 1945 by three discoverers, Jacob Marinsky, Lawrence Glendinning, and Charles Coryell. The original name was supposed to be clintonium after the lab that it was produced in, but it was suggested by the wife of Charles Coryell to be named promethium. To make the metal, promethium 3 fluoride was used in 1963 to measure the properties of the metal. It was made by analyzing the byproducts of uranium fission and by bombarding neodymium with neutrons. Jacob Marinsky was born in Buffalo, New York. He is one of the first discoverers and producers of the promethium metal. He is a chemist, but his only really big discovery was promethium. He was among the Manhattan Project scientists who signed a petition against dropping the atomic bomb on Japan. This is also true for the other two discoverers, Charles Coryell and Lawrence Glendinning. Charles and Grace Mary Coryell are partners, like husband and wife, but not really much is known about Grace Mary. So the only fact about her was that she was the producer of the name. Charles was born in Los Angeles, California, and like I said before, he was among the Manhattan Project scientists. After World War II, he joined the MIT, which is the Massachusetts Institute of Technology, and he conducted research in fission fine structure and beta decay theory. And he was a faculty member in inorganic and radiochemistry. Lawrence Glendinning is probably the most successful out of the three, but not much information is known about him. He was born in Bay City, Michigan. He joined Oregon National Laboratory in 1949 and he remained there until his retirement in 1985. I say he is the most successful because he won the award for the American Chemical Society's Glenn T. Seaborg for nuclear chemistry in 1974. Promethium can be found in only a certain number of things because it's only used in research, most of it. It can be used in luminous paint, nuclear batteries for guided missiles, watches, specialized atomic batteries, a light source for signals, and in the future, it could be used for portable x rays. In the pictures, I show a watch and a battery. And promethium was the alternate for radium, which was used in watches before, but since radium was considered very toxic and dangerous, they started to use promethium. The only common bond was promethium trioxide, and in the image shows the powdered version of that. Here's the atomic structure. It has 61 protons and 84 neutrons. Here's all the energy levels. The interesting facts about promethium is that it has no biological role or function. The only trace amounts have been found in nature, and it's the only rare earth radioactive metal on the periodic table. It's highly radioactive, so it's considered toxic. The last rare earth metal on the lanthanide series to be discovered was promethium. It is prepared in a lab, and it's named after Prometheus, who stole fire from the Greek gods for the courage and pain needed to synthesize it. No promethium is in the Earth's crust, but it was discovered in the spectrum of a star that I can't name right now, but it was 520 light years away. Here are my sources. Thank you.